Hello Year 11, this is Mr. Pretty John here, and well done, you've completed Component 1 and Component 2 of your Geography GCSE this year, 2023, superb. I want to talk to you now about Component 3, the Fieldwork exam, and I want to go through some things with you about this exam. It's about 20-25 minutes long, so please watch this. You can pause it, you can stop it, you can send me a message, whatever it is. Anyway, let's go through where we are. So Component 1's been finished, Component 2's been finished, and now we're on to Component 3, and this is about field work. It's about the inquiry that we did down in Boscastle. The exam's an hour and a half long, and it's worth 30% of your qualification, so it's really important, okay, just like the other two. Component 3 is basically split into 3 sections. The first section of the exam is all about methodology, and you'll be asked about how you might carry out a survey, for instance, okay. Part B is how you might use that information, okay, and then investigate the data that you collected, okay, and they will provide the data as well, so you don't need to go away and revise the data. Part C is where you apply that and you try and think about how you might evaluate it, say how it's better, how it could be improved, and the concepts of geography to it. So you will be asked questions about your own experiences of fieldwork. So don't worry if you weren't there, because I'm going to go through this aspect as well. We went down to Boscastle and we carried out 2 particular projects. We carried out a physical study, which is all about the River Valency, the river that runs through Boscastle. We talked about how it changes shape downstream. And the second one was about second home ownership. Again, we did some questionnaires and we found out about inequality, okay, the difference between the haves and the have-nots, those who can afford a second home and those who can't. Now, the main focus this year for the fieldwork exam is the use of transects, okay, like cross sections. And the conceptual framework is about inequality, like I said, the difference between those who maybe have certain things in their lives and those who don't, okay. Now, Component 3 is split into, Component 3 is about the fieldwork process, and the fieldwork process is basically 6 stages, okay. Now, I'm going to go through those 6 stages now. It's all about how you collected the evidence, how you processed it, how you presented it, how you then analyze it, what conclusions you draw, and then where you say what could be done better next time, how you evaluated it. So the first thing that we did is we decided to come up with a hypothesis. A hypothesis is like a statement. It's a statement of truth that you believe to be the case, and then you go away and you investigate that hypothesis, maybe with some key questions. And the thing that we were going to investigate, okay, along the River Valency was the River Valency changes shape downstream, okay, and that's something that we set out to investigate during our trip to Boscastle, okay. That's a statement, okay. We then needed to test this hypothesis. We came up with it and we thought, right, how do we test the fact that the River Valency changes downstream? Well, we decided we were going to measure the discharge, how much water there was in the river itself. And we were going to find out how the river width and how the depth changed as we went downstream. And then we're going to look at some map work, for instance. We're going to see whether the river really begins to meander. Okay, so we could say that yes, the River Valency changes downstream, yes it does, or no it doesn't, okay? Now, we collected data on the day itself, okay, and we needed to make sure it was accurate. We used measuring sticks to measure the depth of the river. We used measuring tapes across the width of the river. And we used flow meters, these flow meters which we used to chart to work out the velocity. And when we were looking at inequality as well, we did questionnaires. We investigated and researched with local people and businesses about what they thought about second home ownership. Now, where are we going to collect our data? Well, for the river survey, We parked where it was accessible, down in Boscastle over here, and then we walked up the very steep hill, if you remember. We walked along the valley, and we then went all the way along down through St. Peter's Wood to the footbridge over here. And that's where, here's the footbridge you can see, and that's where we decided to collect our first piece of evidence, because it was easily accessible. You could simply step into the river, but also there was sufficient amount of water to make it safe for us to work in. And that's an important thing. The risk assessment had been done, and we decided that this is the best place. It was an ideal location. Okay. We then later went down a bit further beyond Minster Wood, and that's where we collected our second piece of data on the river. And of course this map also showed us, and we used this secondary information to show how the river changed shape as it went downstream. Now, how do we collect data? Well, the exam board needs you to know about 4 different ways, okay, about the way that we sampled the data. They are random, systematic, stratified, and opportunistic sampling. What are those? Well, random sampling is where you simply go for a random number of people or a random number of spots along the actual river, or even across the cross section. Okay, you could use random number charts, and the good thing about being random is that it kind of removes bias, particularly if you're interviewing people. You could just randomly select people, and you get a kind of a better breadth of people across the area. A disadvantage is that you might end up with all of the numbers in one particular area. So if we were doing the cross section, we went with random numbers, we might have done, say, 20, 22, 24, 28, and then 52. So they all clustered around the 20s. Okay, but we didn't use random sampling for the measuring of the transect. Systematic. Now, systematic is what we did use when we measured across the river. We went at a certain number. We went every 50 centimeters across that river, okay? And that meant that it was clear, and we got a really good transect diagram. The only problem with using systematic is that it may mean that you miss out a particularly deep spot in the river, okay? Or if you do systematic sampling questionnaires, it might mean, if you're going every 2nd or 5th person, it might mean you miss out on variety. You might end up only interviewing a certain age group. Now, stratified is a way of trying to eliminate the issues of random and the systematic sampling. So what with stratified is you choose, for instance, 2 groups, well, beg your pardon, 4 groups here. You might choose some young people you're going to interview. You might choose some middle-aged, or, well, let's say 21 to 40, and then 41 to 65, and then 65 and over. And you say, right, I'm going to interview 1 person from that age group, 65 plus, 1 from 41 to 65, and 1 from 18 to 40, and 1 from 0 to 18. And that means you get a better cross section. You can be sure that you get all the categories. You've got to be sure that there are those types of people there, and maybe you used stratified sampling when you were doing your questionnaires about inequality in Boscastle. Opportunistic. Well, opportunistic is you simply just choose whatever's the most convenient. Now, we chose opportunistic sampling for the site on the river. We chose it because it was easily accessible, and it was a good opportunity to get into the river. When we got in the river, we then used systematic sampling. Okay, it might not be truly representative. Maybe we should have gone for systematic sampling along the river. Maybe we should have gone every 500 meters. 1,000 meters, 1,500 meters, and that would have been more systematic, but we didn't have time, and it wasn't necessarily easy to access the river. So in Boscastle, to summarize, for the physical geography, okay, we used opportunistic sampling, and then we used systematic sampling. Okay, so we decided, right, this is the most accessible place, opportunistic, and then we decided, right, systematic, we're now going to do it every 50 centimeters. We're going to measure the speed of the flow. and the depth. And some of you, as we can see over here, measured the size of the stones as well in the bed load. For human geography, you may have used some random sampling, okay, where you just chose a random group of people, or you may have used a bit of stratified. You might have selected age groups. You may have said to yourself, right, we'll get some young, we'll get some middle age, and we'll get some old people. Now, when we were out there, we were collecting primary data. Okay, so primary data is the stuff that you collected yourselves, okay, and hopefully it was accurate, hopefully it was reliable, although you may evaluate that certain things of it weren't. Now, it's all recorded on this data collection sheet, certainly for the physical geography. You also had questionnaires for the human geography, and we wrote down weather of the day, okay, the weather during the week. We got the width of the river. We worked out how the width of the bank full. Bank full is where it would be if it was completely full, the river, okay. And then we measured a certain number as we went across the river cross section. Now, secondary data is data that has already been collected by somebody else. Now, we went to the river gauge, if you remember, and that data is constantly recording the height of the River Valency, and you can see here on the computer screen, and that is secondary data. Maps are secondary data. Use of Rightmove to find house prices is secondary data. Okay, so all of those sorts of things are the sorts of things which you will have been using. So secondary data is something that somebody else has collected. Quickly, hopefully you know this, quantitative data is all about numbers, okay? The data we collected on how fast the river was flowing, the pebble size, you know, how deep the river was, those were all numbers. The qualitative was opinions, okay, so it was what people thought about second homes. So a combination of both was what we collected. Now, we then took it back to the classroom and we processed it. Now, you may have collated the information, you may have collected in a whole load of information from your friends and borrowed their data and used it, so you ended up with a large amount of collated data. And then with that, you can do some processing with all of those numbers and all of those questionnaires and all of those surveys. And you may work out the average, okay, the median. You may work out the range, the difference between the highest the depth and the lowest depth, okay, the biggest pebble and the smallest pebble. You may have worked out a percentage of people that were of a certain age group, okay. So that's where you are processing the evidence. And then you had to present it. Maybe you presented it as a choropleth map with the scale over here, okay, the darker the color, generally the more there is. This is a choropleth map showing population. You might have used a topological map, which is a map which just gets rid of lots of data and makes it a lot simpler, like the London Underground map. Here is a transect, okay, a cross section or river cross section. Here's the depth of the river, and here's the distance from the left bank, and here is the plot of that information. So have a look at those. Remember, this presentation is all available for you on the website. I'll show you that shortly. Okay. Maybe you produce some proportional symbols. So the bigger the circle, okay, the more there is of something. Here are cities in India, for instance. You can see New Delhi is a little bit bigger than Mumbai, and you could take that and you could see it's probably about 20 million people. So you must have a scale, okay, and the bigger the circle it shows, the bigger there is of something. Over here, we have a pictogram, something that's visual, easy to interpret, so you can quickly see some information on it, and they can be very powerful for making something straightforward to read. Maybe we used kite diagrams, and these are like transects, okay, where you, for instance, were doing some footpath erosion data, and you are able to see how much grass there was, how many dandelions there were as you went across a particular footpath itself. Triangular graphs are graphs not like a scatter graph where there's two sets of data, but with triangular graphs there are three sets of data, and in this case, the primary sector, the secondary sector, and the tertiary sector. So you can use 3 sets of numbers to produce a triangular graph. Right, then you've got that information and we can analyze it. Like I said, we can look at trends, maximum minimums. We can look at any anomalies, anything that stands out. Was there a particular place where the river was flowing particularly quickly? Or was there an interview that you did with somebody from a huge distance away who had travelled a great distance to see Boscastle in contrast to everybody else? And then, okay, you can start to point out trends and patterns. Well, here's one. The width of the river increases from 2 meters at the source to 15 meters at the mouth of the river. Now, that would be a statement. It would be a good way of using that data to back up our overall hypothesis later on. Now, again, like I say, here we are. Here's Mr. Francis in the river, and he was measuring the depth. In fact, somebody else was measuring the depth, and you can see them there, and he was shouting out the numbers to people on the side. Okay, and it's important that you remember and you're able to record this information. And then you draw some conclusions. When you've collected that data and you've sourced it and you've put it all together, you drew some conclusions and you said, yes, my hypothesis was right, or no, it wasn't, or maybe somewhere in between. And then you evaluate, just like you as sportsmen and sportswomen at the end of a performance in music or something like that, you think, what is it that I did well? What do I need to do better next time? And the evaluation in your fieldwork is the same. Okay, you identify problems. Maybe the gauge didn't work properly. Maybe the tape measure wasn't quite straight. Maybe when you did the questionnaires, the people you asked were they didn't give accurate information, for instance. Maybe you didn't ask enough people. Maybe you say to yourself, actually, we should have gone and returned to the site maybe 10 different times during the year. Obviously, we didn't have time for that, but that's an evaluation, okay? Data collection, was there a range of primary data collected? Well, on the river, we only really went to 2 sites, and we went on 1 day of the year. Is it something that was there any bias in the data? Did you only ask old friendly people in those questionnaires, or did you have time to go up and ask businesses? Did you have time to go and ask retired people, young people, middle-aged working people? So that is something that an evaluation would have done, and you are expected to have a critical think about this. Keywords. Well, I've been through plenty of these already. Again, you go through a variable, something that can change in a practical investigation. Anomaly, something that stands out that's different. Discrete data versus continuous. Well, discrete is like a shoe size, okay? It's like a size 9, size 10, size 11. You don't get size 9.32, for instance, okay? There are discrete data, okay? There's a set amount. Continuous data is something that gradually changes, okay? For instance, your weight, you gradually increase your weight as you get older, okay? So just knowing those differences there, you can watch the video in your own time. Bar charts, okay? Generally, you should leave a gap between bar charts, okay? And they can compare different places and numbers. Bivariate data is data for 2 different variables. Okay, here we go. Bivariate, 3 hours studied, student 1, test score 90. Okay, 0 hours studied, 76. 2 sets of data. Here we have a bivariate data because you have an eruption for minutes and waiting time between the eruptions, okay, in minutes 8 E. You can see there's a positive correlation in that the eruption is longer, it's a geyser, and in the United States, and when you get really long eruptions if there's a long wait between them. Spatial, relating to space, okay, not relating to occupying space, not space as in space up there. So the spatial layout of something, okay. Here it is, we have spatial layout of child mortality, areas where there is a large amount of child mortality and areas which are not quite so high. Divided bar charts, okay, and remember, with divided bar charts, okay, you need to measure, let's say here for instance, the number of vehicles and the time of the survey between 8 and 8:10. Look, 0 up to 36, okay. Then the next amount, that's for cars. Lorries, which is this category here, it is not right up to 40, is it? It's actually only 4 because it's that distance from there to there, okay? And the same with bus, that is 4. Now you can then percentage these to make it a little bit easier to compare between areas, okay? And there's the time of the survey and so on. Maybe you use those. Choropleth map I have talked about before. This shows deprivation, areas where there's lots of poverty and where there's low poverty, okay? Depending on the lighter colour is where there's least poverty and the dark colour where there's most poverty. Now Isoline maps are quite good. They're like contours on a map, but they join up numbers of equal amounts. And this is a one of pedestrian counts. So you can see that all the numbers inside this isoline are higher than 50. All the lines between this one here are between 40 and 50. So isolines just attempt to join up equal amounts. So this line here is effectively 50. This line here is effectively 40. So they are a good way of just identifying patterns. Flow maps, well, a flow map is the thicker the line, the more there is of something. Look, this is on buses per day, so you can see clearly, if I would say that, I would say that there's about 100 buses between Middlesbrough and Skidding Grove every day, whereas that's a lot. Between Whitby and Loftus, okay, you'd be saying maybe there was 20 buses. So the thickness of the line indicates how many buses there are. Photographs. Well, you probably took a lot of photographs during your field trip work, and hopefully you label them up, and it is important, okay? You can't just have house, for instance. It has to be detailed, as you can see here with more information. Here we go. Number 1 is this one here, traditional shape of windows and roof over porch, but with a built-in garage. This suggests a house built since 1980. So just detail in those labels. Hazard mapping is a way of showing areas which are dangerous and those which are not. This is low hazard down here in the south of Montserrat and up here in the north. Okay, it is quite dangerous because it's red. Again, you need a key. Hazard mapping enables populations to know where it is actually safe. Hierarchy. Okay, the most important is at the top, okay, the capital city, and as you go down they become less important, okay, but there are more of them. So there's a lot more villages than London, for instance, okay, in sheer numbers, but obviously villages are not as important as London. Transect, well, that's something, a key focus for our fieldwork, and you can see here a transect across a eroded footpath from X to Y. As you go across, okay, you can see in this particular area it's very eroded, so there's very little grass, okay, and you can show this on a transect. So as you move from, say, X, let's say that's at 0, as you go across the transect to 20, there is lots of grass here, well, tussock maybe, and then there's less there. I don't think that one matches that one, but anyway, you get an idea. And this is called a kite diagram, and this is a transect, like a cross section in the river that we did. Likert surveys show a change between two ends of an opinion. You can either strongly agree with something or strongly disagree, or you can be somewhere in between. Heat waves are more common now. 18 people said strongly agree. 2 people said strongly disagree. Scattergraphs. Well, this is bivariate data, 2 sets of data. Here's the depth of the river over here, and here is the width of the river. So, as the depth of the river increases, so does the width. Okay, as the river goes downstream, it becomes deeper. It becomes deeper and it becomes wider. Positive correlation, as one variable increases, so does the other. Negative, okay, goes down. As one variable increases, the other variable decreases, and then if it's scattered all over the place, there is no correlation. Okay, and you can see on this one, hopefully, it's a positive correlation, although number 7 is an anomaly. Bipolar surveys, kind of similar to Likert surveys in many ways, but they are using numbers here as well. Environmental quality from -8 up to 10 in this particular case. There's an error in that one. That should say 8, shouldn't it? Okay. Anyway, that's a bad chart. So, these are the sorts of things which you might have done when you collected the data. Okay. You could have done a crime survey, for instance, on equality in the area. Now, at the end of this particular PowerPoint, I've put a whole load of past paper questions. Okay, look at this question here. Question 1 from 2018, 2 advantages of using systematic sampling, okay, to collect data along a transect, okay? Well, it means that you get a straightforward, well, let's just go all the way back to the systematic sampling, which we can see, okay, here it is. It covers a range of locations and you can use it in the whole of the survey areas, and it's quick and easy to do. 2 marks for that one. So go back through, okay, and use the past papers to help you. I'm not going to go through all of those. Now, okay, remember, on the website, Mount Kelly Geography, you can find all of this information. It's found under revision. Okay, here we go. I've told you about this before. There's the component 1, component 2. We've moved on from that one. Now we're on to component 3. Here is the presentation I'm going through, and here are past paper questions. So click on that one, and it will show you past paper questions for past paper 3, component 3. Here is a brilliant piece of coursework by a student. Now, where do you find that? Well, you find that, look, GCSE Fieldwork. We went in 2021, and you can click on this. Well, there are 2 here, 2 examples of student coursework. This one wasn't from our year, but this one is. You click on that, and it will take you to a piece. So even if you didn't go, you could read through this. Look at the introduction. Look at the process. Look at how the methodology is worked out. Okay. Quantitative data. Look at this brilliant labeling showing the direction of current, talking about sediment size, discharge. So, and how the students created this transect of site 1. Okay, so I strongly recommend you have a look at that particular one. Okay, qualitative data, and here's some information, almost like a desire lines, how far people had travelled to Boscastle, who they interviewed. Analysis and conclusions and evaluations. Reminder, you find that on the website under GCSE Fieldwork. And if you want to be reminded of the pictures, okay, there are pictures of the field trip there as well. Okay, so you can remind yourselves of what we actually did. Okay, past paper questions, and the booklet is there as well, which shows you exactly what I expected you to do for the field work. So please take the time, go through something, okay, and if you need anything extra, come and find me. Otherwise, good luck, keep working hard, okay, go for it. Well done, Team Geography.